Working? So now I can make the assumption that everybody in here has a working version of Eclipse for which to do their homework assignment. Yeah, whatever. Okay, so last time we were talking about all the different primitive types. Now, what's a primitive type variable again? Okay, built-in variable, only capable of holding a single value. Why do we have so many different ways of holding integers? Why do we need bytes, shorts, ints, longs?
Sizes and how long it's going to be because of binary.
Because of binary.
I mean, not binary, but wait.
We're one class removed from the explanation.
Memory and programming efficiency.
Memory and programming efficiency. Why do we need that? Why was memory? Okay.
When the older programs were written, there was only so much space available to write the code for.
Okay. So when the grandparent language that these primitives came from, when it was popular, when it was written, memory was at a premium. So we didn't have tons of it, so we needed to break things down to be able to... You missed a quiz. You missed a quiz. Killing me. It's funny, your cousin's always late too. Is it like a family thing? So in any case, back then they had to provide a whole bunch of different ways for storing different sizes of integers so that we could be as memory efficient as possible. Modernly, we don't care. We got tons and tons and tons of memory, and we don't even use it efficiently anyway. So that's why we just keep adding in more, right? Weren't we talking? You had 32 gigs of RAM. But he's prepared. I mean, he can write horrifically inefficient programs. He can download horrifically inefficient programs, and he's got plenty of room to spare. It's like having I don't know, an 80-room mansion with only 2 people living there. Stay in a different room every night of the month. What's up?
So it's just preparation for the state.
That's right. Okay. So we talked about bits last time, ones and zeros. And all of these numbers, these 8 bits and 16 bits and 32 bits, computers store these guys as a big binary number. Okay? Because computers like numbers, and they are also digital, so they deal with things as ones and zeros. We're human beings, we have 10 fingers, and that's how we count, base 10. Okay, well then we talked about Unicode. Unicode was related to the char primitive type, which is an unsigned 16-bit integer, 0 to 65,535. So that's the 65,536 unique characters that can be mapped from an integer, a 16-bit binary number, to an actual character. So Unicode is the successor to ASCII. Successor to ASCII. ASCII contained the 256 American codes. And then, we only have, so many letters and numbers and symbols, and then there's like playing cards and crap like that. And I think I tried to show that to you last time, but the terminal didn't know how to interpret a lot of them. But Unicode adds symbols from other languages into that. Okay. Now, let's talk about floats and doubles quick. So a float is akin to an int, except it can hold decimal point values. Integers do not know how to hold a decimal point value. They do something called truncate. So if I had an integer 3.14, and I tried to stick the value 3.14 into an integer, what value would it actually hold? 3. What if I tried to put the number 3.94 into an integer? Okay, that's the difference between rounding and truncation. All right, if this was rounded, 3.94 would become 4, right? Truncation, we just cut everything off after the decimal place. So whether this is 3.94 or 3.14, it just becomes 3. Okay? So integers deal with truncation. If we try to shove a floating point value into an int, it just truncates it. Doesn't try to do any fancy rounding or anything. Now the reality is most compilers will yell at you. Say, possible loss of precision. Are you sure you want to stick a number with 9 decimal places into an int where you're losing all of that? All that information's gone. All right, that makes sense? So truncation is what happens with an integer when, well, with a double or a float when we put it into the form of an integer. So cut off all values after the decimal point. Does not round. All right, so floats are kind of like the decimal point version of ints. Doubles are like the decimal point version of longs. Now, interestingly enough, and I think I mentioned this last time, most of us, when we're writing code, use integers all the time. So if you look at, when you Google examples of programs and stuff like that, you'll see them using ints constantly. When an int isn't big enough, then they use a long. Now for floating point values, logic would say, oh, then they would just use a float, and if that's not big enough, they would use a double, right? Actually not the case. For floating point numbers, they almost always just start with doubles. So your kind of go-to tools for integers is store it as an int. For floating point numbers, store it as a double. So these would be the two kinds of values, ints and doubles, that you would probably see the most of. Well, actually, out of this list, you'd see int, chars, doubles, and booleans. That would be what you would most likely see in your programming voyage. All right, so now going back here, actually, let's go back a little farther. Back to this slide about how do human beings solve problems. We said we use our memory, we ask questions, and we do repetition. So variables is how a computer programming language emulates our memory. And we do this through primitive types and object types. Object types we're going to talk about later. Primitive types we just finished talking about. So now we need to look at, in terms of a programming language like Java, how do we actually use variables? Now we know what they are, how do we use them? Okay? Variable syntax in Java /C/C++/C#. I'm going to keep throwing it back at you that it doesn't matter what programming language you're programming in, and that's really a truth. So you remember that when I laugh at you when you're like juniors and seniors, and you come to me and says, you know, I'm not very good at C#. I'm really more of a Java kind of guy, and then I'll exterminate. All right, so variable syntax. We have type followed by variable name, optionally equals value. So here, I'll write this. I'll just do it a couple different times. So I'll say type var name, type var name equals value. So these are two different ways of defining. So this is variable definition. Okay? And we'll see examples of both of these. We'll go into Eclipse. Eclipse is an IDE. What's an IDE again? Integrated Development Environment. It's what it stands for. What is it?
Text editor with syntax already.
Okay, so text editor specifically for programming. That has some built-in tools that make life easier as a programmer. Hopefully some of you saw some of these as you were doing your homework with Hello World. Hopefully you actually typed in the Hello World program as opposed to just copy and pasted it from Google or something. I mean, I don't necessarily care, but you would have experienced some of the features. So one of the nice things is it does opening and closing curly braces for you. Once you throw an opening curly brace in there, it automatically gives you the closing curly brace. I used the example this morning about a sandwich. When I'm writing code myself, if I'm out at in a text editor here, do that. And I'm writing a hello world program. When I put this opening curly brace in, I immediately kick it down a line and put the corresponding closing curly brace right off the bat. That way you don't forget about it later. Then I jump up a line. So think of this as your 2 pieces of bread for a sandwich. You get both pieces of bread out and you start slapping stuff on it, right? And then in the end, put them together and you're good to go. All right, so then I put my code in between. All right, so one thing that IDEs do for you that's very helpful is they help you match your curly braces so you don't forget these. So going out on a limb, if you were having problems with too many curly braces or not enough curly braces when you were doing a Hello World program, my guess is some of you probably pasted a Hello World program in to begin with. And then Eclipse maybe got kind of confused and tried to start matching extra curly braces to curly braces as you were pasting them in, but then you had the extra ones from the closing curly braces already there. So you got too many curly braces? Go ahead.
You followed the tutorial, it pretty much did literally everything for you.
Follow which tutorial?
The tutorial for Eclipse, like it pretty much wrote the Hello World program for you.
Oh, okay.
Yeah.
So
It shows you how to do everything and how to write it all.
okay.
So it's really nice.
So really, you're saying that there shouldn't have been an excuse for anybody for anybody having any problems with this.
Yeah.
So anybody who had any problems with this was an idiot.
Yeah, that is
So raise your hand if you had any sort of issues with this, because he's calling you an idiot. Okay, so sometimes you do need to get used to with the IDEs the quirkiness of them. If you do start pasting code in, it might detect your opening curly brace before it figures out that you pasted in a closing one and gives you an extra closing one, that kind of stuff. So don't paste code because you're smarter than that googly thing, right? All right. Well, here, I'll say that now. I don't care if you use Google when you're working on your homework or something, but don't just paste code in to paste code in. Try to understand what it's doing. Okay? Because competence is what you're looking for here. It's how you accomplish it. If you're going to work in your homework with some buddies from class, I don't care. If you all want to turn in the same program, it doesn't matter to me. It'll show up on your exam if you don't actually know what you're doing. And that's going to suck because that's 40% of your grade. And typically, if you have done your homework and you're getting decent at programming, you'll get like a 90-something on the exam. If you haven't really done your homework and you don't really know what you're doing, it's not like you get a 70. You get like a 7. It's complete incompetence that you write on your exams. So it would behoove you to actually learn from the homework assignments as opposed to just get them done. All right, so if you paste something in or you work with a classmate and they give you some code, say, well, here's the solution I got and it works. Paste it in, prove to yourself that it works, and then figure out why it works. All right, and get yourself to the point that you think that, hey, if there was a gun to your head, you might be able to solve this yourself. Make sense? It's going to be slow going for most of you at the beginning. You're going to introduce a lot of errors into your code. You're not going to know how to fix them. You're going to spend most of your time, probably the first minimum half of the semester, probably more than that, probably 2/3 of the semester, you're going to spend most of your time fixing broken stuff. But I promise you, eventually, you'll make all the errors that exist. You'll know everything that doesn't work, which leaves just a very small amount of things that actually function. So once you get used to avoiding the pitfalls, right, then all of a sudden you'll start writing stuff that works the first time around. All right. So IDEs do a lot of stuff for you. Opening, closing curly braces, command completion. So if you type in system dot, it'll give you a list of crap that it thinks you might want to put next. So it helps with spelling errors and things like that. A couple people were coming to me with some of their programs not working. Java is case sensitive. So system.out.println with a lowercase s does not exist. System.out.println with an uppercase s does. All right, so Java is very picky about case. All right, so variable syntax in Java. We always have the type because Java is a strongly typed language, which means that we need to always define what kind of value a variable is built to hold when we define it. Okay, we can't just, in other languages like PHP would be a good example of another language that is loosely typed, where we can just create a variable called myvar, and we could put numbers in it 1 second, then somebody's name in it the next. No harm, no foul. In a language like Java, if we want it to hold numbers, we need to set it up as, if we want it to hold integers, we need to set it up as an int. If we want it to hold names, we have to set it up as something else that we don't know about yet. Because we don't know how to hold anything outside of what's on this list right now. All right. So let's go and define a couple of variables. Head over here to Eclipse. So we're going to go ahead and create a variable int a. So that's form 1 of variable creation, variable definition from this slide. Type, var name, semicolon. Semicolons end all things that are known as statements in really any C-based programming language. So anything that's a statement ends in a semicolon, as far as you know right now. Some of you may have run into a problem where you threw a semicolon up there on your code, and all of a sudden it screamed about everything after that. That semicolon should not be there, although it's not illegal. So, for example, I could leave that line of code just like that, and it technically wouldn't be wrong outside of it being main. Main has to work a certain way, but for any other method, this would not be incorrect. But if you had your opening and closing curly braces after that, and you've had some crap in there, all that would be negated by this closing semicolon, because this would end the statement as opposed to going on to this stuff. All right, so little things like that are stuff that you need to look for when you have problems with your code. So we'll say int a right here. So we've defined a variable named a capable of holding an integer. What's the current value of a? Yeah, we haven't given it a value. It's going to get a default value. Now notice it's kind of screaming at us here. The local variable a may not have been initialized. That's the little error message we got, and we're going to say we don't care. Oh, I have it set up as whatever. Let me go this route. Well, here, I'll just talk about it. The Java compile, the Eclipse defaults to a higher level of error checking, which is actually probably good, because what I'm about to tell you is that you should never try to use a variable after it's been initialized. In an older language like C, if I were to find a variable a, and here we'll actually go and do this. Int a, and we would, let's just print out the value of a is, don't worry about the %d thing there, it's a magic trick. All right, so we're going to define a variable named a here, and notice that in a language like C from the early 70s, let's say, uses the exact same way to define a variable as Java, which is much, much, much newer. All right. Then we're going to print something, so this is equivalent to our system.out.println. It's just prints it differently. We're going to print out what the value of a is, and this %d thing is a placeholder. Don't worry about it. And it's going to print out the current value of a. Now, I just asked the question, what's the current value of a? And you said it doesn't have a value. We never actually gave it a value, right? So we're going to go ahead and compile this. and we get the current value of A is 0. So it was actually given a default value. Now that's actually dangerous. Some programmers rely on those default values. They just know, oh, well, I just know if I define it and it's an integer, it starts off at 0, so why waste my time making it a 0? Well, what you've just done is you've introduced potential future bugs into your program. If a future version of the Java runtime environment decides it's going to change the default values, maybe instead of it being 0, maybe it becomes -1s as default, meaning uninitialized, let's say. All of a sudden, if you have all your logic based off of an assumed default value of 0, things now are broken. Does that make sense? So never assume that a variable will have a default value. If you want it to start off as a 0, make it a 0. All right, and looks like the latest version of Eclipse. The Java compiler has that ability built into it. You can choose whether you want to compile more strictly or less strictly. Default used to be less strictly. In fact, I'm kind of interested. Whether it's Eclipse or the actual Java compiler's default. So I'll write a Java program here, just created A, didn't give it a value, then we're going to try to print it out. Oh, it is the default now. All right, so default is stricter, which is good, because I'm, like I just told you, always initialize it. Never assume it has a value. So my preference, this used to be a warning. Like, hey, just to let you know, this thing might just not have a value in it, so enter at your own risk. So always put a value in there that you want as your starting value. Now, having said that, back on the slide here, I've defined 2 different ways of creating variables. This first way is completely legitimate, though. Type followed by var name. Just don't try to use that variable until after you've given it a value. So I can define A on one line, and then I can give it a value on the next line, if I'd like. Or I can say int b is equal to 7, all in one line. That make sense? So when I print out the value of A, it's going to print out the current value of A, which A was defined right here as a variable of type int. So now I have a variable named A that is capable of holding an integer, and as of right now there is not an integer in there. Then I went ahead and I assigned the value A, or the value 5 to A. This equal sign here is the assignment operator, not to be confused with the equivalence operator, which we're going to talk about soon, maybe today actually. Really just depends on how we pace things out here. Okay, so the single equal sign is the assignment operator. It's used to assign the value on the right to a variable on the left. That's an example of the use of the assignment operator. It can also be embedded into the definition of a variable up here. So really, this one line right here is a combination of defining a variable and giving it its initial value, all in one line. Okay, but the single equal sign is assignment. All of you in here will confuse that at some point. When we're going to be talking about something called Boolean expressions today, probably. And when we talk about those, we use the double equal sign to test if one value is the same as another value. And at some point, you're going to put the single equal sign in there instead of the double equal sign, and you may not get an error, depending on where you're using it. You might be assigning the value of one variable to the value of another. Okay, and we'll look at an example of that. So A gets defined here, A gets its value here. B gets defined right here and gets its value in one line. When we go to print it, we'll print out the value of A, which is 5. We'll print out the value of B, which is 7. So the output of this should be 5 and 7. Make sense? Now, by definition, variables can vary. Okay? Their values can change. So I can come down here and I can say A is actually 13. Right here, just to prove they hold negative numbers. A is actually equal to negative 13. All right? And then I'll go ahead and I'll print A again. So now I'll get 5, because A was equal to 5 at the time I printed it here. Then I'll get 7, because B was equal to 7. Then I'm going to change the value of A, and I'll print A again. A is now 13, or negative 13. 5, 7, negative 13. Now remember, all programs begin and end with main. So when I run this program, when I hit the little play button here, it starts the very first line of main here and just starts walking down to the end of main. Right after the opening curly brace, all the way to the ending curly brace of main. Now, later on, we're going to have main sending us off to other places. So we'll be, doing this line, then this line. All of a sudden, main will say, by the way, go and call this code all the way over someplace else. Come back when you're done doing that. All right, so this is mission control for our programs, main. So as we're walking through this, we do this line, define a variable, give that variable a name, skip a line, create another variable and give it a value. And I actually meant to say give that variable a value there. Print out the value of A. Print out the value of B. Change the value of A to negative 13. Print out the value of A. That's the order in which things will occur as you walk through that program. Make sense? Now, what about chars? Let me get rid of some of these extra lines here. All right, so define a variable name A, set A equal to 5, print out A again. The output of this program is going to be 5 and A. Okay. Now, why is that? Notice that this one, I've surrounded A by single quotes. Okay, single quotes. Single quotes is how Java and C++ and C# and C, how they identify a char primitive type. Really how they differentiate that from a variable name. So let's talk about what's actually happening in this line of code. System.out.println, for right now, we'll talk more about where this guy actually came from, but for right now, we just know this prints stuff, all right? And it's going to print whatever we put in between the opening and closing parentheses of that guy. So we need to identify these guys. So when I look at A, in that case, we know A is a variable name or A is undefined. So for instance, if I put in B there, it's going to yell at me. It's going to say, B cannot be resolved to a variable. You didn't define it because we took the definition of B out. All right, so if we were to print out A, it assumes we're talking about a variable. Why? Because we haven't given it any sort of special syntax to let it know that it's actually something else. We'll give you a little foreshadowing here. When we talk about strings, strings are surrounded by double quotes. This guy's a string, this guy's a char. This guy's a variable name that we hope exists. This guy is what's known as a literal. Okay, this is the literal, a hard-coded value, are literals. Okay, 5 is 5 is 5. We can't change the value of it. We don't get to say, well, you know, I don't like the rules of math, so we're just going to say 5 is actually a 7. KK, thanks. Not going to fly. Notice that Java's not a fan of this. Hover over the little error here, and it says the left-hand side of an assignment must be a variable. The assignment operator used to assign the value on the right to a variable on the left. Left-hand side must always be a variable. Otherwise, everything else is a literal. This is a literal. It's a literal char value. This is a literal. It's a literal string value, and we don't know about those yet. This is a literal. It's a literal int value. Make sense? All right. So we can print out literal values. No big deal. Because what happens inside of println here is anything that's in there gets resolved to its value. Things are often more than they seem. When Java gets to that line right there, gets that portion of that line and sees the A, it immediately identifies the A as being either a variable or an error. So first thing it's going to check is, has the user defined a variable named A? In this case we did, everything's cool. But now it needs to determine what is the value contained within A. We have to unwrap that present before println knows how to display it. Okay? Println doesn't display variables. Println displays the value contained within the variable. Make sense? All right, so that's called variable resolution. Resolving or determining the value contained within a variable. Okay, and this gets back to our memory. The actual computer memory, which simulates our brain. So we talked about the ways human beings solve problems. One of the ways we solve problems is by remembering things. And we would really, really, really suck at solving problems if we couldn't remember stuff. An example, and we've seen it in movies, when people have short-term memory loss type problems. And in movies, they're depicted as being funny, but it's really debilitating. Folks who have any sort of memory loss, but certainly short-term memory loss, they don't know what happened 5 seconds ago. That becomes very, very problematic in terms of solving even the most basic problems. So certainly we can see how important memory is in solving problems. So variable resolution deals with taking a variable name and resolving it to its actual value stored there. Now in computers, where are those values stored? It's stored in your 32 gigabytes of RAM. Okay, in the wasteland of memory, mostly unused out there. It's like Lord of the Rings. We're traipsing through gigabytes after gigabyte after gigabyte of barren land until we finally get to where this 32-bit value is stored. Here's some interesting math for us. How many 32-bit values can you store in your in your computer? So 32 bits is how many gigabytes? Well, a bit is 8. A byte is 8 bits. So 32 divided by 8 is actually 4 bytes. Times, I'm sorry. Huh? What did I do? 32 bits divided by, no, that's right, divided by 8. 32 bits is 4 bytes. 32 bits divided by 8 bits per byte gives us the number of bytes. So we have 4 bytes. 4 bytes is actually equal to 0.003 kilobytes. Divided by 1024 is actually equal to a really, really tiny number of megabytes. Divided by 1024 is an even tinier number of gigabytes. So that's a number of ints that can fit inside of a single gigabyte. Well, that's how big an int is. So we multiply. So that's how big an int is in terms of gigabytes. So how many of those do we have to get to 32? So we're going to go all the way to the beginning here, and we're going to do 32 divided by all of that crap. So that's 32 gigabytes divided by the size of, well, the number of integers in a gigabyte gives us this big number of integers. So let's say, what's that? So 8,589,934,592. That's the number of numbers your memory can remember. The number of numbers your memory can remember. His memory. All right. Big numbers. All right. So variable resolution is the act of going and searching in our computer memory for where that actual variable's value lives. Okay, so A is going to point somewhere in real memory. That place in real memory actually holds the value. We're going to go and find that actual value, and at runtime, when our program's running, this variable resolves to the value contained within at runtime. So it's actually printing out the literal 5 after it resolves the value contained within the variable A. So this line and this line are actually doing the identical thing. Just the second line took one less step. We didn't have to resolve the variable because we gave it a literal. Make sense? So variables always resolve to their value. Should capitalize that. Always resolve to their value. That's going to become important as we start reading our code and trying to figure out what we just wrote. What is it supposed to do? What did we intend for it to do? And that becomes the difference between these 4 lines. This is a variable. Variables resolve to its value. That guy has a value of 5. This is a literal. Literals resolve to their value. They're already their resolved value. So this is the value A. The char value A. Println knows how to print out chars. This is the string value A. This is the literal 5. The int value 5. Okay, so all of these are going through the exact same printing process, but the printing process knows how to resolve a variable and give this literal value, knows how to display chars, knows how to display strings, and knows how to display ints. Similarly, it knows how to display doubles, floating point values. Make sense? Okay, so that's our introduction to primitive type variables. Now, what can we do with variables besides just display them? Well, we already saw one thing. We can change the value of variables. We can have their value vary. Okay. Well, what else might we want to do? Well, we're dealing with computer programs. Computer programs seem to be mathy. So what if we did math crap to them? So we have the math operators. And these are going to be completely brand new to all of you. We have the plus sign, the minus sign, divide, multiply, asterisks, not an X. Okay? So we'll start with just that list. Let's give ourselves a couple of variables here. I'm going to make this a little bit more convenient. So we'll say int A, int B equals 7. int c is equal to a plus b. Then we'll print out c. And let's also print out a plus b. Well, what's the value of a? 5. What's the value of b? What's the value of c? 12. If I print out c right here, what's it going to print? Because it resolved the value stored within the variable c to get to the 12. What's going to print out here? 12 as well, but it actually got to the 12 differently. It resolved the value stored in A. It resolved the value stored in B. It added them together because we gave it the addition operator. And then it gave us the result, which is 12. 12 and 12. Variables always resolve to their value. Here I'll add a little thing, at runtime, which is what we really care about when our computer's running, resolves to its value. Okay. What about a minus b? A minus b. What's the value of c going to be right here? Negative 2?
2. Yeah, negative 2.
What's the value here going to be? Negative 2? All right. Let's do this. A divided by b. What's this going to print out? Ah, 0. Why 0? Truncation. 5 divided by 7 is actually what? 0.714, blah, 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 right? But integers don't know how to store that. Integers know how to display, well, they know how to store whole numbers. So they do what's called truncation. They cut off everything from the decimal point on. So what do we have before the decimal point here? A 0. Now, what about here? It's a little fuzzier, right? Both 0. Why?
Because A and B are both integers.
Since A and B are both integers, this does integer division. If A and B were both doubles, and just pretend like you don't see that for a second. Completely unimportant. We don't know about this yet. Okay, so since if we made A and B both doubles, C is going to be 0, but A divided by B is going to be our 0.71, blah, blah, blah. So in that case, since it recognized that A is a double and B is a double, when we do division, it's treated as floating point division. If at least one side is a double. Good.
Can you divide a double by an int?
Sure.
Vice versa?
Yeah, so if we make this an int, it'll still be treated as a double. If at least one side is a floating point number, it treats it as floating point math. Okay? Now, in this case, we had to trick it. We had to say, I want you to do this math, and then this is called typecasting, and we'll talk about that again later. But this says, force it into a different format. Yes, I realize I'm losing precision here. So go ahead and trust me on this one. Make it an int and shove it into this variable right here. Because that's all that'll fit. All right? And that's an important distinction. Integer division as opposed to, let's just say, normal division. All right? If we're dealing with integers on both sides, it will be treated as integer division, and integer division truncates. All right. Now, how many of you remember long division? Greatest part of third grade, right? So, in long division, what is 5 divided by 7? Well, how many times does 7 go into 5? 0 times. 0 times 7 is 0 with remainder what? 5. Remainder 5. So 5 divided by 7 is 0 remainder 5. Correct? So we have another math operator show off here. This is the modulus operator. And this is for integer division, long division. This gives us the remainder of integer division. I'll show you this as an example. So let's go ahead and let's just get rid of C for a second here. And we'll change B back to a int. And we're going to print out A divided by B, which is a 0. And we'll print out A mod B, which should be the remainder of that integer division. That's going to give us a 0, and it's going to give us the 5. That make sense? So these two operators, when we're dealing with integer math, work hand in hand. One gives us the division side of it. The other one gives us the remainder side of it. Now I'll tell you this. The modulus operator is actually one of the most powerful tools we have as computer programmers. We'll see it over and over and over again this semester and how we can use that. I'll introduce the idea to you real quick, and that way I can say that you've heard the thing, and then when you don't apply it correctly later on, then I can laugh. It'd be funny. Okay, so modulus operator, this is the remainder of an integer division. Any positive number mod a positive number n, that is, well here, any positive number x mod a positive number n, that is x mod n, results in a value in what range? I could see this being a quiz question very shortly, maybe next class. So any positive number x, pick your favorite positive number, 7. Mod a positive number n, so the other side of the division, pick your favorite number, favorite positive number. X mod n will have a result, and that result will have a value in what range?
Between 1 and
Not 1. I heard somebody say something.
0.
Why 0?
0 and
Not n either.
oh,
Close.
Any positive number and 0.
A positive number and 0, no. This is what we're about to write here is an extremely powerful thing that we're going to use over and over and over again all the way into your professional programming career.
between 0 and 1 less than n.
Yep. 0, and n minus 1. And this is something we all already knew. So let's take the number 5. Let's divide the number 5 by 1. How many times does 1 go into 5? 5 times. What's the remainder? 0. Okay, let's take the number 2. How many times does 2 go into 5? 2 times. With what remainder? 1. How many times does 3 go into 5? 1 time. With what remainder? 2. How many times does 4 go into 5? With what remainder? How many times does 5 go into 5? 1. With what remainder? 0, 1, 2, 3, 4, and then it looped back. Why wouldn't we have a remainder of 5 if we're dividing by 5? Yeah, you screwed up the division. It went in an extra time. Right? You know, well, technically 5 divided by 5 is 0 remainder 5. Make sense? Can't have a remainder of 5 if you're dividing by 5 because it means 5 went in another time. So if we say 5 divided by 5, the answer cannot be 0 remainder 5. The answer is 1 remainder 0. So we can never actually have a remainder of 5 when we're dividing by 5. That's why our answer is always n minus 1 is the largest value we can have as a result of modulo. Does that make sense? Actually, a very important little axiom here. Very important. Has to be an integer. That's a mostly truth, but for our intents and purposes, it has to be an integer. All right, questions about that? We're going to use that over and over and over again, that little fact there. The result of modulo is always in the range of 0 to n minus 1, where n is the number we were dividing by. Okay? You can see that popping up on a quiz anytime. Hint, hint. Just excellent quiz question. Just saying.
Can you repeat the question?
Well, it would be, what is the range of, the question could be something along the lines of, what is the range of values of the result of any positive number being divided by any other positive number for modulo? Similarly, you could ask the question is, what's the, for long division, what's the range of values that the remainder can be? It's the same question, just asked in a less techie way. Okay? Questions about modulus? All right. And hey, I'll just show this to you in action. We'll do another loop because we've seen them before, but I haven't taught you loops yet. We'll see them shortly. Probably next class, I'm guessing, actually. So we're going to start off at int is equal to 1 then, we'll go to 10,000. And we'll just keep divided by 5 and printing out the remainder. Over and over again. So we're going to take our value, starts off at 1, then it becomes 2, then it becomes 3, then it becomes 4, then it becomes 5, then it becomes 10,000. After some filler in the middle there. And we'll see the biggest we ever get is a 4. That make sense? Very, very important. We're going to apply that to a lot of problems. You don't know why yet, but that fact can be leveraged in a lot of different ways. Okay. Class is out at 11:20. Is that right? Okay, good. Good. Boolean expression. You guys learned this in 200. What's a Boolean expression?
True or false?
Any expression that boils down to a single value of true or false. Any expression that boils down to a single value of true or false. That is a Boolean expression. So, examples of Boolean expressions. Well, here, let's throw some Boolean operators first. Let's look at some Boolean operators. Also, these guys will be completely foreign to you. You've never seen these before. Things like less than or equal to, greater than or equal to, equal to, the double equal sign, as opposed to the single equal sign, which is the what? Assignment operator. So single equal sign is how we assign a value to a variable. Double equal sign is our Boolean operator for testing equivalence. Is one value equivalent to another value? Not equal to. So if we're going to, we might say these are the arithmetic. Is it spelled right? Magical. Well, I do have a PhD. So I should be able to spell arithmetic. It's really pathetic, actually. It goes way downhill after you got 26 or so. It's like your peak. 26 is your peak, and then after that, gone. Just gone.
Rain or
Yeah, pretty much everything. Yeah. Yeah, I've lost, I think I actually lost my sanity well before 26. Be my guess. Yeah. But that actually comes out like as entertainment. I see, right? Yeah. What was I talking about? Oh, arithmetic Boolean operators. Okay, so all these guys are used for creating Boolean expressions, which are any expression that boils down to a single value of true or false around numbers. Okay, so for example, let me give myself a couple of variables again. Int A is equal to 5, int B is equal to 7, and we're going to go ahead and we are going to do a system dot out dot println. A is less than B. What should that be? 5 less than 7. True. So that is a Boolean expression. Any expression that boils down to a single value of true or false. B less than B. Is that even legal?
it's gonna be false if it's not legal.
Can I write this? Does it even make sense to compare B to itself?
But it has
Well, it's gonna be
value,
false.
so-
Ah, it does have a value.
So,
Every variable resolves to its value at runtime, right? So what's B?
7.
What's B?
7.
7 less than 7. False. Yeah, perfectly legitimate. Somewhat of a waste of time, but perfectly legitimate. Make sense? And even though this seems like a stupid little exercise, it's so important. You always need to view variables in terms of how they resolve. Otherwise, you're going to get tricked. So often, something will look like it's one type of value, but it actually is something else. And we'll see plenty of examples of that. Okay, but at first glance, you might say, oh, that's a number. But when you actually resolve everything down, maybe it turns into a Boolean. Okay? A not equal to B. It's a true statement. It is true that A is not the same as B. And by the way, you cannot have spaces in between. The Compound operators like that require them to be right next to each other. Okay? Good.
May I ask why we put spaces in between like the variables and
That?
yeah. Why don't we do that for all of these?
You mean, why don't I write it just like this?
Yes.
You could.
Okay.
Nothing wrong with that.
And it would still run?
Yep, runs just fine.
Okay. Just easier to see.
Easier to read.
Certainly easier to see, right?
Yeah.
So, same thing. I can write this entire program on one line.
Okay.
Java doesn't care. Here we go. Boom. And there we go. Clearly, we know what that program does. Prints out a true. And this is a simple little stupid program, right? Imagine we actually had a game. It's actually a competition every year. I think they still do it. Is who can write the longest one-line program that does something.
So when you just type it out normally and then just delete it back to one line?
They actually have some rules with it. Like you have to use like compound statements. Like they actually have to link as opposed to just doing what we did here. But a program that literally exists inside of one line that does something. I think one of the years somebody wrote like Pac-Man. Like kind of a rudimentary version, but a working version of Pac-Man on one line of code. And it was a long line of code. All right, now here a nice feature of Eclipse is it has, as we've seen before, auto indentation properties. So you can highlight everything. Let's just say you remove something. You already have some stuff indented, but you remove something that was on the outside. So actually everything should be shifted over one level. You can have it do it for you. So you can highlight everything, right click, go to source, go to correct indentation. On a PC, that's Control-I. On a Mac, it's Command-I. Oh, that worked beautifully. Maybe I need to do formatting for that first. Yeah, there we go. Yeah, so this puts it in bad format from my perspective. I hate when it puts the curly braces there. And there's a setting in here where you can change the way it does it. But, you know, certainly was better, right? So it'll format it for you. But if I go in here and I mess with my curly braces like that, and I want to fix that, I can just highlight it, hit Command-I on a Mac, and it'll move everything the way it needs to be.
I like how it moved it back to where you wanted it versus putting the curly brace on the first line again.
So, kind of a cool feature of IDEs. All right, so these are the arithmetic Boolean operators. Any Boolean expression, or a Boolean expression is any expression that boils down to a single value of true or false. I will ask you that a lot. Okay, I'll come in and remind me what a Boolean expression is, and then you should all chant. Any expression that boils down to a really creepy chants is what I'm looking for. Okay, true or false is acceptable. I like the whole the cadence to any expression that boils down to a single value of true or false. That'll be one of our go-to phrases in here, and maybe some humming. You guys can decide which side of the room hums, I guess. All right. So these are the arithmetic Boolean operators. Then we have our logical Boolean operators. Logical Boolean operators, we have and. We have or. So and is the double ampersand, no spaces. Or is the double vertical bar, no spaces. We have not, which is just an exclamation point. And not inverses inverts, reverses, inverts. Yeah, inverts, I like that one. It inverts a Boolean operator. So not true is false. Not false is true. Is A less than B? True statement, right? 5 is less than 7? That's true. What if I said not 5 less than 7? Now it's false. In parentheses here, we have A less than B, which is true. Not true is false. Make sense? Again, you have to resolve all of this. So A becomes a 5, B becomes a 7, 5 less than 7 becomes a true. Not true becomes a false. So there's a lot of crap going on there. I should do this. Here, we'll actually just start with this. For your homework. Well, here, I'll say it, then I'll type it in after you guys leave. We're going to write a program where you create a single variable called pennies, and you put in the number of pennies you might have. So in order to change your input, you would come and modify this value. Your program should then calculate how many dollars, quarters, dimes, nickels, and pennies that's equivalent to, and print it out to the screen. Make sense? So 1421, that's how many dollars? 14 bucks. 14 bucks, because we have 100 pennies per dollar.
Do you want the integer values or do you want the totals?
Well, do you ever use portions of a penny?
Well, for dollars, do you want it to be 14.21 or do you want it to be?
No. I want this to be broken down correctly as if it was if you were getting change at McDonald's.
But they don't give change correctly.
So then it really doesn't matter what your program does. All right. So this should print out dollars is 14. Quarters is, there's only 21 cents left, right, after dollars? So quarters is 0. Dimes is 2. Nickels is 0. Pennies is 1. That's the most efficient way of giving this money back, of breaking pennies down into our denominations of, our biggest denomination we'll use is dollars. That makes sense? So for this example, it should print out dollars 14, quarters 0, dimes 2, nickels 0, pennies 1. So we have $14, no quarters, 2 dimes, no nickels, 1 penny. All right? And everything you need to do we learned in class today. So you're probably going to create several more variables and then 5 print statements to print out the value of those variables. That make sense? And I'll give this to you as a starting point. And you should test your program by changing the value of 1421 here to some other values and see that you get different answers for your change. Questions, comments, concerns, bribes? Yeah.
You want it submitted in a screenshot like the last one?
Yeah, you could do a screenshot, or you can even just paste the code in there. So you can just literally take this and just copy it and paste it in there.
Thursday.
Do Thursday. And make sure you also fill out the self-evaluation form, which for all of you, this should be trivial. So you should say, I deserve an A, it all works, blah, 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 KK, thanks. That's fine. I'll train you into doing it over the first couple assignments, and then I'll hold it against you. So let me put this assignment up.